So this is a new question coming from LeetCode. Problem number 242, valid anagram. Okay, it's an easy mark problem. Very nice to understand the new concept. Okay. If you carefully see, this has been asked in a bunch of companies. Again, very frequently asked question, very famous question, pretty old question as well. You are given two strings S and T, and you have to return true if T is an anagram of S. Okay. So what you have to do is you have to figure out whether S and T are anagram of each other or not. Okay. Now, what do you mean by anagram of each other or not? An anagram is a word or a phrase formed by rearranging the letters of the word or phrase. That means two words are anagram of each other if they contain the same set of letters but in different permutation or different rearrangement. So you can say anagrams are nothing but permutation of each other. Okay. For example, rat, car are not anagram of each other, but anagram and nagram are anagrams of each other because they are just the permutation of each other. Okay. So we're solving problem 242. Okay. So we are solving the problem for anagrams. So first thing first that we have to understand about anagrams is anagrams are permutation of each other. Permutation of each other, right? Permutation of each other means, let's say you say silent, okay, and you say listen. These two words are permutation of each other. Permutation of each other means that these two words have got same set of characters, but the rearrangement of characters is different, or the arrangement of characters is different. That's why I'm saying both of them are permutation of each other. So that's what we have to detect, that whether two given words are anagram of each other or not, right? As simple as that. Now, how can we check that? One simple way can be that if both of them are permutation of each other, then a brute force approach can be that you sort both the words. Okay, you sort both the words. If both of them are permutation of each other and you sort both the words, after sorting, you are going to get the exact same word. For example, here we will get E-I-L-N-S-T. Here also E-I-L-N-S-T. If after sorting, you get the same word, that means both of them were anagrams of each other, right? Okay. This is one possible way. And it will be very easy to do as well. Okay. But we can do something better than sorting, because here also sorting will take more number of instructions. Okay. We can do something better than sorting. What can we do here? Now, we know that anagrams are permutation of each other. That means, if we try how to optimize. Now, because anagrams are permutation of each other, we can say that in anagrams, the same set of characters are present with same frequency. Right? Same set of characters are present with same frequency, right? The initial brute force approach said that you sort both the words. If you sort both the words and both of them are permutation of each other, both of them will sort and give you the same word. Then they are anagram, otherwise not. But if you want to optimize, we can avoid sorting. How can we avoid sorting? The bare minimum thing that we are able to think about anagrams is that they have got the same set of characters with the same frequency. So how about we prepare a frequency mapping? For example, let's say you have listen and you have silent. Okay, let's take any word. Let's say this is S, this is T. Let's take S. Okay. Now what I want you to prepare a frequency mapping. What is a frequency mapping? In a frequency mapping, you store the frequency or the number of occurrences of a particular character. For example, here the frequency mapping will be like N is present once, I is present once, S is present once, T, E, N also all as once. This is a frequency mapping for listen. Okay. If let's say you have a word like canteen, what will be the frequency mapping of canteen? In canteen, C is present once, A is present once, N is present twice, E is present twice, and T is present once. Can I say this is the frequency mapping of canteen, and this is the frequency mapping of listen, right? So let's say we will somehow prepare this frequency mapping. Currently, we will park this question that how will we prepare it, but somehow we will prepare this frequency mapping. If somehow we are able to prepare this frequency mapping, this mapping is a key value pair. In this mapping, every entry is a key value pair. So now what we can do is we can check if the other word is also following the same mapping or not, right? So you have two words, you have to check if both of them are anagrams or not. If both of them are anagrams, we can say that both of them will be having the same set of characters with the same frequency. If they have the same set of characters with the same frequency, how about you try to check that whether the other word also complies with this frequency mapping or not, right? How do we do that? Let's see. So what we can do is we can one by one go to every single character. Now we are at S. So we found one occurrence of S. What I will do, I will reduce the frequency of S because I found one occurrence of S. That means this S and this S is balanced. So the frequency reduced to 0. The moment frequency reduced to 0, I'm going to remove it from the map. Then I'm going to go to I. Is there an I present? Yes. I will reduce the frequency of I to 0. If the frequency has been reduced to 0, I'll remove it. Then I'll go to L. Is there a presence of L? Yes. We'll reduce the frequency of L. Now the frequency of L is 0. So that means all the L's are resolved. We'll go to E. Is there any occurrence of E? Yes. We'll reduce the frequency of E and remove E. We'll go to N. Is there any occurrence of N? Yes. We'll reduce the frequency of N and we'll remove N. At last, we will go to T. Is there any occurrence of T? Yes. We'll reduce the frequency and remove T. And can I say the whole key value mapping or the whole frequency mapping is now empty? That means all the characters of S are now resolved by all the characters of T. Hence, both of these are anagrams. Let's take one more example. So let's take S as anagram and T as nagram. Okay, let's prepare the frequency mapping for anagram. So A is present thrice, N is present once, G is present once, R is present once, M is present once. Can I say that? Right? Now, let's start resolving diagram. Okay. We are at N. Do we have an occurrence of N? Yes, we have an occurrence of N. So we reduce the frequency. The moment frequency becomes 0, you remove it. Okay. Now you go to A. Is there any occurrence of A? Yes, we reduce the frequency. Frequency becomes 2. Is it 0? No. So we still have some A that are yet to be resolved. Okay. Now we are at G. Is there any occurrence of G? Yes, it is. So we reduce the frequency and now it is 0. That means all the G's are resolved. We are good to go. We are at A. Is there any occurrence of A? Yes. We reduce the frequency of A to 1. Is it equal to 0? No. We do not remove it. We move to R. Is there any occurrence of R? Yes. We reduce the frequency. We remove it. We got A. Is there any occurrence of A? Yes. We reduce the frequency. The frequency became 0. Now all the A's are resolved. You remove it. And then you get M. And then you get M. Is there a frequency occurrence of M? Yes. You reduce the frequency and then you remove it. That means all the characters are now red. Is the frequency mapping empty? Yes. That means yes, these are anagram of each other. Let's take one more example. This time let's say rat and car. For rat, the frequency mapping will be like R, A, T, all with 1. Let's start with car. Is there an occurrence of C in the frequency mapping? Is there an occurrence of C in the frequency mapping? No. That means you immediately return a false, that these two are not anagrams of each other. Okay. So that's how you can actually solve this problem, that you create frequency mapping of the first word and try to actually map the second word with that frequency mapping. If at last the frequency mapping becomes empty and this whole word also has been read, that means both of them are anagram. One more condition you can check, that anagram should be of always same length. For example, if there's a word Sanket and there is a word Sam, okay, these two words can never be anagram of each other because they have different length. And we just saw that anagram should have same set of character with same frequency. So here you have lesser number of characters available. So you can have a length check that you can directly apply as well. And in this way, you do not need to actually sort your or rearrange your characters, but instead you can actually prepare a frequency mapping and get the answer done. Now, how can you prepare this frequency mapping? This frequency mapping is a key value pair. And what structure helps us to store key value pair? In languages like C++, we have unordered map. In languages like Java, we have hash map. In languages like JavaScript, we have objects. And in languages like Python, we have dictionary. So we can use any of these constructs and try to technically prepare a frequency map for us. Right? As simple as that. And that's how you can actually solve this particular question. First of all, is the approach clear to everyone? The approach was pretty simple. The question was pretty simple. Can I say that? Okay. Let's try to code it. Right. So let's open it up here. Right. Let's first of all prepare frequency map of S. How do we prepare frequency map of S? We say const, let's say MP is equals to an empty object. And we iterate on all the characters of S. So let I is equals to 0. I less than S dot length. I plus plus. Okay. Now, how do we create the mapping? We will check if MP of S of I is actually present. Right. What is MP of S of I? Let's see. So let's say you have a object like this. If you check MP of A, do you have A? No, it is undefined. Right. So that's what we are checking. That do we have any occurrence of the current character? Right. If it is undefined, we land here. Okay. If it is undefined, that means you need to first, this is the first time you want to create the occurrence. So you can say MP of A is equals to 1. Right. Same thing I'll do here. MP of S of I is equals to 1. Right. Now, if you check MP of A again, can you see this time it is not undefined? It is having some value. So it will land in the if check. If it is defined, we land here. And if it is defined, what do you need to do? You need to just increment the frequency. I'll say plus equal to 1. Whatever is the value, you do plus equal to 1. So if you do MP of A plus equal to 1, can I say MP of A becomes 2? Right. So you can see this is the frequency map that we have prepared. Now, before the frequency map, we should also do a length check, that if S dot length is not equal to T dot length. If the length are different, then we should always return false. Now we have the frequency map. With the frequency map, now let's iterate on T. Okay, let's iterate on T. See, simple loop to iterate on T. Now what we'll do is we'll check that if MP of T of I is equals to undefined, that means there is a character in T which is not present in S. In that case, you immediately return false. You do not need to check anything else. You just immediately return false. Else, if we found the occurrence, what we are going to do? We are going to decrease the frequency, minus equal to 1. If occurrence found, decrease frequency. And you have to check if the frequency after decreasing becomes 0. If the frequency becomes 0, what do? You delete this entry. You delete T of I. Right? You delete this entry. At last, you have to check whether the map is empty or not. How do you check whether the map is empty or not? So you can say object.keys MP. What it will do, it will give you an array with all the keys inside it. So you can check the length of this array, right? You can see the length of this array is 1. If in case, let's say the map is empty, and you check the length, can you see it is 0? So I can do the same thing. Object.keys of MP.length. If it is equals to 0, that means we found an anagram. If it is not equal to 0, that means we didn't find an anagram. Okay, let's run this code. So you can see very straightforward. Whatever I'm saying, I'm writing the same code altogether. If I submit it, you can see accepted again, right? And pretty simply, we've actually solved this problem. And this problem gave us a new technique that we can use, where we can use some kind of a mapping, where you are using some kind of a mapping to store some values that you can retrieve later. Okay. So this introduces a new type of pattern. These kind of questions are also called as hashing based questions. I'll talk about what is hashing in the later set of videos as well. But you can understand that this object or this mapping internally uses something called as hashing for them. So this is a hashing based approach where you are trying to store some values that you will be able to retrieve later.